video runs through how to factorise quadratic expressions. Here are 5 quadratic expressions which increase in difficulty in terms of factorising. Let's have a look at the first one. So this quadratic equation is relatively easy to factorise. We can pretty much do it straight off because the a term is 1. So we know that there's going to be x times x, and we just need to have a look for pairs of factors of 12 that add up to 8. So it's got a lot of pairs of factors of 12, especially if you consider the negative pairs. So we've got 1 times 12 and minus 1 times minus 12. We've got 2 times 6 and we've got minus 2 times minus 6. We could carry on with that list, but we can see with the pairs of factors that we've listed so far, the 2 and the 6. 2 and 6 add up to 8, so we can write those in, and we've factorised this first quadratic. Okay, let's have a look at the next equation in order of difficulty. Okay, so on this one we can pretty much use the previous method to factorise it. Let's put our open brackets there. Here on this quadratic equation we have got a prime number as a and also a prime number as c. So we know that these brackets must start with 2x times x to make the 2x squared. And we know that these brackets must end either minus 1 times 3 or 1 times minus 3. So if we look at this middle number, we see it's minus 5. It's going to need the minus 3 to go there to make minus 6 when those two are multiplied together. So then the plus 1 goes here, and we've factorised that. Okay, let's have a look at the next one. Okay, this next one, we have got a is prime and c is not prime. Okay, so we're starting to get more and more possibilities when we're dealing with numbers that aren't prime. So it's going to be a long process to try and experiment within brackets. So at this stage, when it gets this complicated, we are best off having a formal method to solve this. So let me run you through that. First of all, 3 times 24 is 72. This is what we're going to use to find our list of pairs of factors, and we're going to be looking for pairs of factors that add up to 18. Okay, so we've got 2 times 36, not 18, 3 times 24, not 18, 4 times 18, not 18, 2 times 12, and that's the 1. So now what we do is split up this middle term with these two pairs of factors. So 3x squared plus 6x plus 12x plus 24. Now we'll take these two and factorise them. So 3x comes out as a common factor, times by x to create that term, times by 2 to create that term. Okay, good. Now we need to factorise these two. 12 out as a common factor. 12 times x creates that term. and 12 multiplied by 2 creates that term. Okay, so now we have two terms, and we're going to take out the common factor, which as you can see is what's in the bracket. As it comes, we need to multiply that bracket by 3x to create the first term, and we need to times this bracket by 12 to create the second term. So this factorises our original quadratic. And now for the next example, we can see that A is not a prime number, but that C is. We can see that we've got lots of possibilities about how the brackets could start, with A being a non-prime number. So we'll stick to the formal method to factorise it. So A multiplied by C minus 12. Let's list pairs of factors that add to 4. So we've got fundamentally 2 times 6 minus 2 times 6 makes 12. And that adds up to 4. So we need go no further. Let's split up the second part of the quadratic. Okay, using our pairs of factors. Okay, so 4x has changed to 6x minus 2x. Take out a common factor here. So 6x was the common factor. Now I've factorised it. 2 out as a minus 2 out as a common factor here. Okay, then factorising these two terms, x plus 1 out as a common factor. Right, now for the most difficult one, because we've got A is a non-prime number and C also is a non-prime number, so we definitely have to use the formal method here. Okay, so 8 times 12 is 96. Okay, so let's look at our pairs of factors for 96. Okay, 2 times 48. We've got 3 times 32. All the time we're looking to see what adds up to 20. 4 times 24. 6 times 16. 8 times 12. And bingo, we're there. So let's do the method again. So we're splitting up the second term with our pairs of factors. Okay, then we factorise the first two pairs. Factorise the third and the fourth terms. Okay, and then we factorise these two. X plus 1 comes out, common factor. And we factorised it. Let's go back to the first one. If we were solving the first equation, it would look like this. So it would say factorise and solve that equation. So we factorise it, and we can see if we've got two numbers multiplied together to equal 0, then one of them, or both of them, has to be equal to 0. So the way that this bracket equals 0 is when x is minus 2, and the way this bracket equals 0 is when x is minus 6. So x equals minus 2 and x equals minus 6 are the solutions to this equation, this quadratic equation. Let's have a quick look at the second one. if this question was factorise and solve this quadratic, we factorised it, and to solve it, this bracket has to equal to 0, so x is 3 in that case, or that bracket has to equal to 0, so you'd rearrange 2x plus 1 equals 0. Take 1 from both sides, divide by 2, x is minus a half. Okay, so in this one, the solutions would be x equals 3 and x equals minus a half. I hope this video has helped. Thank you for watching.